Hey guys, today we're going to be talking about a couple of different properties, the power of a power product, or power property, and product of a power property. Okay, so we'll go ahead and start with a few examples and see what we have. Okay, so you have 13 to the fifth to the third power. Okay, so if you were to expand that to the third power, what would that look like? Well, you would know that you'd have 13 to the fifth times 13 to the fifth times 13 to the fifth. Okay, that 3 exponent just says that you're multiplying 13 to the fifth by itself 3 times. Okay, so if you were to use our multiplication properties from last week, you know that if you have the same base and they're multiplied together, you can add the exponents. So if you add 5 and 5 and 5, that would of course give you 13 to the 15th. Okay, and what do you notice when you compare these two? You have 13 to the 5th to the 3rd, and you have 13 to the 15. What do you notice? Well, you notice that if you multiply your exponents when you have power to a power, you can get your solution. So let's try another one real quick. Okay, example 2, if we were to expand s to the 7th squared, that means you have s to the 7th that's multiplied by itself 2 times. Okay, and since you have the same base, they're multiplied together, we can add our exponents. So that would give us s to the 14th. But if you look back here at our power to a power property, you can just multiply them together, and that would also give you s to the 14th. Okay, so that would be your solution. Okay, so what I'm wanting you to take from this section, I want you to write in the box right here. Okay, so write power of a power. Okay, power of a power, and I want you to write this. A to the m inside of parentheses to the n equals a to the m times n. Okay, so that is the rule for power of a power. Okay, so let's try a few together. Okay, we have 4 to the 4th to the 3rd power. So you would take 4 times 3, and we would get 4 to the 12th power. Okay, what about this guy over here? And that little box thing that should have been a negative sign. Okay, so this should just be the number -3. Okay, so since we have a power to a power, we know that we're supposed to multiply the exponents. So we have 5 times 2, which is 10. So we now have -3 to the 10th power. Let's try a couple more. Hey, these are really quick. 4 times 5, we know that to be 20. So our final solution would, of course, be n to the 20th after you multiply those together. Okay, one more real quick. Okay, we have x to the 3rd times 3. We know 3 times 3 is 9. So that would, of course, give us x to the 9th. Okay, so that gives us a basic understanding of a power to a power property. Let's try a few examples that are a little bit more difficult and apply what we have learned. Okay, so go ahead and flip to the next page. All right, so let's go ahead and apply what we've learned. First thing I want you to do in that little box, that should be a multiplication sign. So just put a big dot there that represents multiplication. Okay, so we have s to the 10 to the 6th power. We know that product of a, or power of a power, you multiply the exponents there. So 10 times 6 is 60, so we have s to the 60. And then s to the 8 times 2 is 16, so that would give you s to the 60th times s to the 16. Okay, well, what did we learn when you have the same base and you're multiplied together? Well, remember our property from last week is that you can add those exponents. So 60 plus 16 would give you s to the 76. And that would be our final solution for that problem. All right, let's give another one a try here. Okay, and again, I want you this time, make sure you're paying attention, this time in your box, we're going to do addition. So put addition in your box this time. Okay, so let's go through our properties. We have m to the 4th times 3, so that tells us power of a power. We're going to multiply those. So 4 times 3 is 12, so we have m to the 12. And then we have our addition sign. And then we have m to the 5 to the 5th power. So if we multiply 5 times 5, that of course gives us m to the 25. Okay. Now, can we add these? Well, we know that we don't have the same exponent, so we cannot add these. So this already is in your lowest reduced form. It's already simplified. Okay, a few more. Let's try this example number 3. Okay, and this time in your blanks, we have a negative 10, so put a minus sign in there. And then in front of the 4, you have multiplication. Okay, so make sure you get those in. Okay, so let's go ahead and take a look at this. And let's take it piece by piece. Okay, we know we have power of a power because we have 3 times 2, or 3 to the 2nd power here. So that gives us negative 10 u to the 6th. And then we have u to the 5th to the 9th power. Okay, and 9 times 5 is 45. So we have negative 10u to the 6th times 4u to the 45th. Okay, and this gets us to a problem like we had last week. Okay, we're going to have to multiply the coefficients, okay, and then add the exponents. So negative 10 times 40 would give us negative 40. Then we have our variable, which is u. And then, since we have the same base and we're multiplied together, we can add the exponents. So 6 plus 45 gives us 51. Okay, so that would be your final solution. All right. And before we do the next one, I got a quick joke for you. All right, here's the joke. Why did the cross-eyed teacher lose her job? Think about it. Think about it. Because she couldn't control her pupils. You like it. All right, so let's try this one real quick. This time in your blank, I want you to put a plus sign. Okay, so put a plus sign. So let's go through here. We have w to the 3rd to the 4th, so we know we need to multiply that, power of a power property. So we have 8 w to the 12th, then our addition sign. Then over on the other side, we have the power of a power property again. So we have 6 times 2, which is 12. So we know we have 7 w to the 12th. Okay, but this one's a little special since we have the same base on these two expressions and the same exponent, we can then add our coefficients. So we know that 8 plus 7 is 15, so we now have 15 w to the 12th. You can only do that if you have the same base and the same exponent when you're adding two expressions. Okay, let's try one more. All right, on this one you got to really pay attention. Make sure that you get all these blanks. Okay, so in the first one we got a negative sign. Then in the big one you have a multiplication. And then in your other two blanks you also have negatives. Okay, so let's move through here a little bit. We have a to the 3rd times negative 4. 3 times negative 4 gives you a to the negative 12. And then we have to multiply a to the negative 2 times negative 3. And negative 2 times negative 3 would give us a to the 6. Okay? So now, once you have these same base, same base and they're multiplied together, you can add the exponents. And if you add negative 12 and 6, that would give you a to the negative 6. But what do we do with negative exponents? We can't have them. Okay, so if you have a negative exponent upstairs, remember you send it downstairs. So we would have 1 over a to the 6 for our solution. All right, I would like you to, actually you don't need to do that, don't worry about it. Okay, so hopefully you've gotten a few of these principles down and we can take it from there. See ya.